Okay, so we're going to go over our February Evaluate test, problems 8 through 11, and then 13 and 14. You should have already completed this pear deck, and now we're going to go over it. So you can check your answers. You can also get on your Evaluate test for February and see what you marked on the actual test itself as well. It says, what are the factor pairs for the number 16? So first of all, I know that a factor is a number that I multiply together with another number to get an answer in a multiplication problem. I know that a pair means two of something. So factor pairs means two factors, two numbers that I multiply together to get 16. It says one factor is listed in each of the boxes below. Drag the numbers to complete all of the factor pairs of 16. You can't drag on here, so we're clearly writing them in. Here's what I want you to pay attention to. If you are putting two numbers in a box, okay, there's already one in each box. You have more than three numbers down here, which means you will not use all of the numbers, okay? So what you're asking yourself is, if you want to get a product or an answer of 16, what am I multiplying by each of these numbers to do that? So I would say 1 times 16. So I've used that one. I would have dragged that up there. 2 times 8 is 16. So I would have dragged that one up here. And then what do I multiply by 4 to get 16? 4 times 4. And so I would have dragged up the 16, the 8, and the 4. And I would have left the 1, the 10, the 14, the 5, and the 3 as not being dragged up. Okay. All right. Number 9. Says drag the multiples of 3 into the box below. Now, remember, multiple is skip counting by 3s. So what I want you to do when you do this problem is start with 3s and skip count and write them down. 3, 6, 9, 12, 15, 18, 21, 24. Now I can stop at 24 because I want you to pay attention to the numbers that you can drag up. The highest one is a 23. So once I get higher than 23, I don't have to continue with my multiples. So now what I'm going to do is I'm going to compare this list to here. All right, do I see a 5? Nope. So I would not drag that one up. Do I see a 21? Yep. So I would drag this 21 up into the box. Do I see a 9? Yes. So I would drag the 9 up into the box. Do I see an 8? Nope. Do I see a 13? Nope. Do I see a 23? Nope. What about an 18? Yep, there's 18. So I would drag that one up as well. So you need to be thinking about multiples, skip counting. 3, 6, 9, 12. This is also the answer to 3 times 1, the answer to 3 times 2, 3 times 3, 3 times 4, because I'm going in order. Okay. All right. Number 10 says, which number sentence is true? Remember, the pointed side right here is always going to say less than because it's pointing to the lower number. Okay. So if it's talking about that first number being less than, the pointed number is the pointed side is facing the smaller number. So let's compare these numbers. These both have an 8 and a 2 for 82,000. Then I'm comparing my 900 to my 400. Well, 900 is not less than 400, so that's wrong. Here I'm comparing my 54 and my 54. Those are the same. I've got 900 and 900 here. Those are the same. So what I'm comparing is my tens. I'm comparing the 60 to the 80. 60 is less than 80. So that one would be correct. But we're not going to stop there. Let's check our other ones. I'm comparing the 38 to the 34. Is 38 less than 34? No. So that's why that's wrong. Here I'm comparing my 74s. Those are the same, 74,000. So I'm comparing my hundreds, 700 to 400. 7 is not less than 4. So that one is wrong. This is the only one that made sense. All right, number 11. So it says, Patricia multiplied 6,209 by 8. Which set of work could Patricia have used to correctly find the answer? So what I want you to think about when you do this is to think about this number being broken down, because you see all these parentheses? That's what it's doing. It's breaking down these place values right here. And each one of them, you can see 4 place values because there are 4 digits. And then each one I should be multiplying by 8. So here's what I want you to see. Am I doing times 8 in all of these? Yep, times 8. So all of these numbers all have a times 8. So that's not going to be what separates them, okay? What's going to be, and they all have multiplication symbols inside all the parentheses. They all have addition symbols outside of the parentheses. So all of that's the same. So what you're looking for is the inside numbers. So here's what I want you to think. When I do the box method, okay, I'm doing times 8, which is why you have an 8 in all of them. But when you do 6,209, you're breaking it into your place values. So here's that first place value, 6,000. Here's 200. My next place value is 0 because I don't have any in the tens. And then my ones place is 9. So here's the 6,209. When I come down here, here's 6,200, 0, and 9. So that one looks correct. This has a 6 and a 6. This is not worth 6. It's worth 6,000. So when I come down here, that has a 6,000. So that could be right. Then I come over here and I have a 20. Did I put a 20 up here? Nope, I put 200. So that's why that one is wrong. Okay. So the only one that could be correct is that one. All right. So for number 13, it says which statement is supported by the decimal models below? So you're choosing one of these decimals. Over here, though, I need to turn this into a fraction. So let's count our shaded pieces. 1, 2, 3, 4, 5, 6, 7 pieces are shaded out of, so here was 7, 8, 9, 10, so 7/10, okay? And then over here, let's count 1, 2, 3, 4, 5, 6, 7, 8. And I'm not going to count all these, but I know that when I have one of these big, huge cubes divided up into little cubes, there are 100 of them. So first of all, you can do this so that you know which ones you're looking at, 7/10 and 8/100. Okay, so let's compare. Do I have 7/10, 7/10, 7/100? That's wrong because I can't have 7/100. I have 7/10. Okay, and that's a 7/10. Now let's look at our 8/100. 8/100, 8/100, 8/10. I can't have 8/10, so that one's wrong. So that was one way to eliminate a couple. Then what you're going to do is you're going to look and you're going to compare them because that's what's different about these two, right? They both say 7/10 and they both say 8/100. So what's different is the less than and the greater than. So when I come over here, I know that my shading has way more shaded with my 7/10. So my 7/10 is bigger. So I know that the open side has to face my 7/10. That's why this one is correct. My smaller number would be over here because it's the pointed side. But since it's not the smaller number, that one is incorrect. All right, number 14, our last one today. It says, which expression below is equivalent? What does equivalent mean? Do you guys see something that is kind of like that word? I hear that word equal, or part of it anyway. So equivalent means equal to the expression. These are expressions right here. And it's saying equal to this, 34 times 19. So first of all, pay attention to this symbol. It's a multiplication symbol. This is addition. That rules that out. Addition problem will not be the same as a multiplication problem. So that was one thing I could eliminate. Now I'm looking at 19 and 34, 43, 91, 39, and 14. So if it's equivalent to this, I can flip-flop which one comes first or second, but the numbers have to stay the same. So 34 is not the same as 43, and 19 is not the same as 91. I flipped those tens in one places, so that's wrong. Down here, I flip-flopped the numbers. I flip-flopped the 9 and the 4 to make it 39 instead of 34 and 14 instead of 19. That's also not correct. This one is correct because all I did is I switched which number went first, the 19 with the 34. That's why this one is correct.